Hooks Claude Master. Let's dive right into this explainer. Listen, if you've spent any time at all working with an AI agent like Claude Code, you've absolutely run into this one very specific, incredibly frustrating developer pain point. Most of us just naturally assume the AI is totally in charge, right? Like, it decides what commands to run, when to format your code, what files it's going to touch. But what happens when you're sitting there pulling your hair out because the AI just doesn't follow your strict instructions? So, what if you need a guarantee? Think about it for a second. Imagine a scenario where you don't just want Claude to, probably run your code formatter after it edits a file. You need it to absolutely guarantee that it happens, zero exceptions. You really don't want to be relying on the AI just happening to remember a rule that's buried way down in your system prompt. Okay, let's break down the difference here, because it's actually pretty huge. On one side, we have probabilistic prompts. These try to influence Claude's behavior using natural language. And hey, it usually works, but not always. On the other side, we have deterministic hooks. These are actual hard-coded shell commands that always execute. They give you strict, definitive power over your entire workflow. And that brings us to the key stat of this whole concept: 100%. Literally 100%. By default, Claude Code can get interrupted, it can get distracted by a complex task, or it might just flat out ignore a formatting instruction. Hooks completely eliminate that variability. A hook runs exactly when you tell it to, 100% of the time, no exceptions, no excuses. So, when do these hooks actually step in? Well, they plug right into the Claude Code session lifecycle at 4 very specific injection points. We've got session start, which triggers the moment a session opens. Then there's pre-tool-use, happening right before a tool fires, which is great if you need to validate or block it. After that is post-tool-use, perfect for things like formatting or logging right after a tool finishes up. And finally, notification, which hits when Claude is just sitting there waiting for your input. All right, so how do we actually build one of these? Let's take a look at the anatomy of a hook. You configure these inside a JSON settings file, either at your user level or the project level. And it really comes down to 3 essential parts. First, you have the event. That's the lifecycle moment we just talked about that it's listening for. Second is the matcher. This is an optional filter, so you can specify exactly which tools should actually trigger the hook. And third is the command. This is the actual shell execution, the HTTP request or the script that you want to run. Now, once that command runs, it has to communicate back to Claude somehow, right? It does this using standard exit codes. The hook script essentially reads the context passed to it over standard input as JSON, does its thing, and then responds. And exit 0 just allows the action silently, and exit 2 blocks the action entirely. And the cool part is, Claude actually sees your explanation for exactly why it was blocked. Or you can get fancy and use exit 0 combined with standard output to inject some extra JSON context directly into Claude's next turn. Okay, let's step away from the theory for a minute and ground this in a concrete, real-world example. We're going to talk about auto-formatting a TypeScript file using Prettier. The goal here is simple. We want to automatically format that file the absolute second after Claude edits it. Picture this kind of setup. You configure a PostToolUse hook to actively watch for any edit, multi-edit, or write commands, and you point it straight to a simple bash script. The very moment Claude writes unformatted, messy code to your source file, boom, the hook fires instantly. It extracts the file path, it checks that the extension matches, and it runs Prettier. The perfectly formatted file lands right on your disk without Claude ever needing a prompt to do it, and without you ever having to manually check. It's like magic. Now, before you jump in and start writing your own hooks, we need to cover some absolutely crucial best practices. First up, if you are dealing with slow tasks like running a massive test suite or a heavy build process, you need to use the async setting and set it to true. If you don't, you're going to freeze the entire Claude Code interface while it waits. Nobody wants that. Second, always keep your debug output on standard error, not standard out, especially if your hook is returning structured JSON. And finally, and I can't stress this enough, remember that these hooks run with your full system credentials and file system access. So review those hook scripts really carefully. Which brings us to our key takeaway. Hooks turn Claude Code from an agent that usually follows your workflow into one that always does. This is a massive paradigm shift for how we interact with AI. Hooks become the definitive enforcement layer for your development workflow. Literally, they're the difference between sitting there hoping Claude remembers to format your code and knowing with absolute certainty that it will every single time. So, if you're ready to master this enforcement layer, head on over to cloudmaster.net. You can dive into the full chapter there, which actually walks through 3 more real-world examples and some common pitfalls to avoid. But before you go, I want to leave you with a question to think about. Just how much of your daily development workflow are you leaving up to chance right now, when you could be completely guaranteeing it with a simple hook?